Hello guys, we are team number 22 and I'm Rakesh Balsa here. My the teammates are Shivateja, Akshay, Varun and Nitin Reddy. We have successfully created the game Death Ride after sprint 2. Here's the task board and burndown chart. You can see the different components on which a team has worked on to create the game, and this components board.
Hi, my name is Shivateja. I am one of the team member of Team 22. This is my weekly report for Sprint 2. In week 1, I have learned and explored various design patterns, and I have selected command design pattern to implement the menu screen. In object-oriented programming, the command pattern is a behavioral design pattern in which an object is used to represent and encapsulate all the information needed to call a method at a later time. In our game, command design pattern is implemented for menu screen, where we have option of help and also play now. The menu world, loads the world where all the actions do their respective work. Whenever we click on the help control, it will redirect to the controls info, which implements the menu interface. Thus play game and display are overridden in the controls info. Whenever we click on the play now control, it will be redirect to the play now class, which implements menu interface. Here the play game will be implemented from this interface. The level 1 world will be given as input to the menu world class, where the level 1 world will be created. Menu interface has play game and display methods, which are implemented in the respective classes. Let me show you by playing the game. Here comes our game. This would be the main screen. Whenever we click on the help button, a new screen will be coming up with the various key functions of our game. And whenever I click on the play now, the game will be started with the implementation from the menu world interface.
Hi, this is Nitin here. This is my sprint report for Sprint 2. I have implemented the traffic on the road. We needed cars, trucks, and coins to appear so the user can maneuver through the obstacles and collect coins to progress through the game. After much thought, I came up with the factory pattern, as you can see here, where it deals with the problem of creating objects without specifying the exact class of the object that will be created by calling the factory method. We implemented this pattern using the traffic class over here. The car class, which extends actor, calls the traffic class to create objects of traffic. In this case, it would be other car, truck, and coin. The traffic objects are given random number using the random number method as the parameters to set their location. And we can see this over here. There the truck object has been created in the traffic, and the coin has also been created. And there's another coin object, and that's the other car.
Hello everyone, I'm Akshay Talati. I have implemented observer pattern in the Death Ride game, and this is my weekly stand-up report for Sprint 2. In the first week of Sprint, I started implementation of design pattern for game and started designing of user interface for the game. In the second week, started development of the game using observer pattern. In the next week, I implemented observer pattern in the game, and in the last week, integrated functionality with other code. I used observer pattern to update the score and level in the game. As you can see in the diagram, there is a subject interface, and car is a concrete subject class implementing the subject interface. Subject car notifies about score and level to observers by notify observer method. Car class attaches concrete observers by attach method, and concrete observer class has two child classes, score and level. Concrete observer class observes for any score or level update in the car class. When a car collects coins, there is an increment in the level of score by 1, and when user passes level 1, it goes to the level 2 in the game. Concrete observers are attached to the car class to update and reset the score, and maintain level in the game. Now I will try to play the game and show it to you about how it works in the game from user's perspective. Now I'm waiting for the coins to be collected. For the demo purpose, we have kept the number of coins to the 3 for the level 1. As you can see, I'm playing the level number 1 and my score is 1 after I collected the coin. Now I will collect the second coin and my score is updated to the 2, and after I collect the third coin, my level will go to the level 2 and score will reset to the 0. As you can see, I'm collecting the third coin and now you can see I've gone to the level 2 and my score is reset to the 0. So that's how I implemented observe pattern in the death ride game.
Hi, I'm Rakesh Balsa again. When it comes to my contribution, it includes exploring more on design patterns and creating different animated objects in the Sprint 2 first week. And in the following second week, I've done implementation of code for animated objects used in the game. In the third week, functionality of moving and static objects and unit testing. And in the fourth week, the code integration with other functionalities. When it comes to the design pattern I've used is the iterator pattern. Iterator pattern is generally used to get a way to access a collection of objects in a sequential manner without a need to know its underlying representation. Uh, okay, I created an iterator interface which helps in accessing objects in a sequential manner, and a container interface having methods which returns an iterator object. Classes like file images and image repository are created, which implements the container and iterator interfaces that are responsible for the pattern. When it comes to using the pattern to access file images in order, let us see the game. Now, in your game, there are three file images which are accessed sequentially and placed at the back of the car for every 5 milliseconds. So it looks like an impression, like a fire coming in the back of the car.
Hello, I'm Varun. I have implemented two patterns, the state pattern and the proxy pattern for the Death Ride game. This is my weekly stand-up report for Sprint 2. We thought of state pattern for implementing multiple levels, win and game over states in the Death Ride game. As we can see on the screen, this is the UML class diagram for the state pattern. Here, the level 1, level 2, game over and win. These are the four states which extends the abstract class levels, which in turn implements the level interface. Car class uses the level interface to set the state of the game. By default, level 1 is set. In car class, the collected coins and crash is checked. If collected coins are 10, then user passes the level 1 and goes to level 2. And if in the level 2 player collects 15 coins, then user wins. While play, if car hits any traffic obstacle, then game overs. Let's see how it works in Greenfoot. Let's play game then. Okay. This is the first coin. This is the second one. For the demo purpose, we have kept coin collection to 3 coins for level 1 and 5 coins for level 2. So this is the second level. Oops, I missed it. Oh, first coin, second coin. So traffic and coins kind of comes randomly. So this is the third one. Oops, I missed it. Yeah, fourth one. I should not miss this. Fifth one. I won the game. Now we'll see the game over state. Okay, now, whenever in level 1 or level 2, if our cars hits the other car, then game over. The second pattern I have implemented is a proxy pattern. We thought of proxy pattern to show the image for help and play now button without setting it directly using the green foot. This is the UML class diagram for it. We have abstract class image proxy interface extended by control real image and control proxy image. The menu word creates the instance of abstract class image proxy interface, which is the object of control proxy image. It then calls display method of control real image to show the image. Let's see how it is implemented in the greenfoot. The help the and that play now, those are the buttons, and the image, the help and play now is actually coming using the proxy pattern. In the end, I would like to thank every team member for the efforts taken. Thanks to Professor Paul for his valuable guidance, and also thanks for watching the video.